Today's presenter is Paul Wacker. Paul is the Product Marketing Manager for the Industrial Device Connectivity Group here at Moxa. And with that, I'll hand it over to Paul.
Martin, thank you, and thanks to everyone joining us today. We've got a great session today. It's a little bit of a back to basics session, but as we find, sometimes everybody has such busy schedules and so many things at hand that doing this every so often is really a good thing. And with the different types of things folks are doing, it's always good to have some extra tools in your tool chest to handle some interesting types of problems. So as Martin introduced, I'm Paul Wacker. I'll be leading the session for the next 30 or so minutes here and talk about some great ways to extend your Ethernet connections. With that, let's go ahead and get started. And again, if you folks have questions as we go through this, you can kind of submit those via the chat, and we'll take those at the end of the session. In terms of agenda, we'll do just a little bit of review and then kind of look at a few tips for this. I think is a good place to start, as we usually see in these webinars, we've got people with really diverse backgrounds. So just to kind of bring us all together here, let's take a quick look at some of the origins of Ethernet. And it's pretty interesting technology. Worldwide, it's the largest local area network. And looking back at where we came from, Ethernet was developed in the 70s and really became a huge commercial success with 3Com, the founder of which actually was involved in inventing Ethernet. If you look at the diagram up in the right-hand corner, it kind of dates the technology a little bit, with Ethernet having been based upon a bus technology with coaxial cable. That's that round cable that you might have seen in your home, for example, for cable TV. And it's undergone a lot of transformations at the physical layer level, where we've done some interesting things in terms of the technologies used. One of the biggest things that happened was the introduction of twisted pair cabling. That is, moving from that coaxial cable to twisted pair, much like you'd have in today's Cat5, Cat6 type cable. And then also in that physical layer, seeing different generations of the technology to take us today, within data center commercial deployments, reaching to 100 gigabits per second. So remember, gigabits, 1,000 megabits per second. And despite all these changes, the really cool thing is that you can take and coexist with the right type of technology, perhaps a switch, to have that 10 meg coexist with 100 gigabits today with that. Just a quick summary. Basically, the distance doesn't matter, independent of the type of technology you have deployed. It's 100 meters for those of us here that work in feet. That's 328 feet. Your performance may vary. You might find a little more, a little less, depending upon the quality of the cabling you're doing, what type of environment that's put in. But it does give you kind of a good rule of thumb when you're planning your applications that, keep that under that, 300 or so feet for the maximum distance. Now remember, that is going point to point, and a lot of applications are done with a switch, which kind of leads us into what happens when we have to go a little beyond that. So let's take a little look at that. But before we do, let's kind of look at some of the limitations of this, right? I kind of alluded to this in the last slide when we were looking at the specifications, right? So what are things that can affect your performance? I said that, in a perfect environment, we can do this 328 feet or 100 meters. What other things can impact that? Well, certainly, this is based on copper cabling, and as a lot of you folks know, and particularly those of you folks, and I suspect a lot of you are working with industrial applications, there can be other things in the environment that can impact that. That might be things such as other electrical devices nearby. And within industrial applications, we see a lot of things that you're switching large loads, turning a motor starter on and off for a pump or a compressor. If you're doing variable speed applications, you might have a variable speed drive or a variable frequency drive, a VFD. You could have other types of equipment. Maybe within a manufacturing facility, you might be doing maintenance on a system and maybe having to use an arc welder nearby. those can always all create electromagnetic interference, or EMI, and that can impact what's happening. Fortunately, the design of Ethernet is a really well done design, even dating back to the early implementations for twisted pair cabling, where you have differential signaling that's transformer coupled to basically reduce a lot of that noise on the endpoints, and you can actually sustain a lot and very well. Another thing that can happen is differences in grounding. Again, with that transformer coupling with Ethernet, it does a really good job, but it can't protect against everything. Some of the things to look out for are ground faults. This can happen when you have different pieces of equipment powered up by different power sources. Having been an old applications engineer myself in years past, I have seen a lot of damaged laptops where someone had taken a laptop and plugged it into a power strip, not realizing that the electrician had made a mistake and the laptop was powered separate from the panel, and there might have been an outlet that's floating by 115 volts above the panel, thereby blowing out the serial port on your laptop. These things can happen. They're a little more rare today, but it's good to know about these types of problems can exist when doing that. And lastly, the thing probably most important on this slide is thinking about, what other disturbances, maybe a little more of a catastrophic level, can happen if there's damage to an electrical panel, or if there's other disturbances that are more catastrophic, like lightning. Not everything is totally protected. There are different ways to protect this. We'll talk about one of those today, a real simple device you can install to protect against things like lightning in certain applications, like building-to-building types of connections. So Ethernet's really awesome. It has a great design independent of whether you're using 10 meg, 100 meg, gigabit over plain old Cat5 cable, but it's not going to protect against every disturbance that's out there. So let's take a look going a little further here. So our first tip is, what about adding a switch? Sounds kind of simple, but I think a lot of people forget about this simple technique to basically use an Ethernet switch as a repeater. And the way this works is remember that we're doing point-to-point connections, and with these point connections, remember that each link can be up to your 300 or so feet on that. And we've got a little bit of a schematic, and I apologize, not everybody's an engineer, but what I wanted to kind of showcase here is that on each link, you have a endpoint of that RJ45 port on the switch, where that signal comes into the switch, gets converted into logic level on the switch itself, and based upon the processing, you'll have a response coming back out on your RJ45 port, where each of those point-to-point links get cleaned up and passed on to another port. So in this conversion in the switch here, each one of those links can go another 300 feet on that. So the net result is basically that those point-to-point links are cleaned up at the switch level and retransmitted, which gives us a capability to be able to extend our connections through a switch. So if you take just a real simple application, if you have a means, and some of this depends upon your topology, you need to have a place to locate a switch, you need to have somewhere you can power the switch, and so forth. But if we look at this simple scenario, and a lot of times this can be a nice little technique to use. On incoming in the switch, you've got your 300 or so feet over here on the left-hand side. By inserting that switch as an intermediary, you can kick it over far enough to go to that end target device with a really expensive, unmanaged switch. So don't forget about the simple things. Sometimes the simple things are overlooked, and there's really very little impact to your application to go far enough to do that. Now, some people might ask, well, hey, Paul, this is great. Could I do this a couple times? And absolutely, you could actually cascade a couple of switches by going, into a switch and out, and back into a switch and out on there. Two caveats on this: there is a little bit of latency, and generally you're seeing about 10 microseconds of delay through each switch. It might range less or more depending upon which specific switch, but it kind of gives you a little rule of thumb. And there is a little bit of another caveat, being that you do have kind of a single point of failure. If you do lose power to the switch, or have somebody disconnected, you'll lose the devices downstream from that. There are ways to prevent that with other technologies like a managed switch, but kind of keep that in mind. Nevertheless, real simple way to extend your Ethernet connections just by adding a simple switch. Hopefully, some of you folks picked up a tip here, just on our first tip of today, to give you some ideas on what you can do. Okay, let's go on to tip number 2. Now, tip number 2 is not something that a lot of people think about, and one of the reasons I wanted to include this on today's topic, it's a rather new technology, and maybe not a lot of folks know what this is. Let's go ahead and talk a little bit about what that is. So I kind of gave a little bit away here. DSL stands for Digital Subscriber Line, and it's a technology that wasn't specifically created for Ethernet, but it's a way of carrying high-speed data over low-quality, voice-grade copper cabling. Where you probably have seen this before, for those of you that responded to the poll earlier, is through bringing broadband service to residential and business applications. Most of you folks probably have heard of this through telecom companies to provide broadband, right? So what they're trying to do is, hey, we've got copper cabling that brings voice-grade telecom service to your house. How can we extend that to deliver high-speed data? The deployment of that was first done with a technology called ADSL, or asynchronous DSL, that delivered, some great speeds of roughly, and there's been some new generations that go beyond this, but the first phase of this was up to about 6 megabits per second over those same wires that were pulled to your neighborhood and home or business over that copper cabling we have, the traditional phone service. Now, there are a lot of different versions of this. We're not going to go into a lot of detail today of that. If you'd like to know more, let us know after the webinar. We can point you to some great resources for that. But we just want to kind of share some of these really interesting technologies with commercial off-the-shelf technology to deliver that to you quickly and easily to do that. And so we'll talk about a couple forms of that and a couple commercial off-the-shelf or COTS technologies for that. But one of the things we want to talk about here is that the distances are limited by cable length, much as you saw the limitations with Ethernet being deployed, being limited by cable length as well. So let's go a little step further. So DSL, Digital Subscriber Line technology, what else can you do with this technology? Okay, we kind of saw a little bit of that, that we can extend these connections. But what's different here is there are a category of devices called DSL extenders or DSL Ethernet extenders that are able to take this telco technology and deliver it to extending Ethernet over, low grade, or if you will, unconditioned, sometimes some different names for this technology of copper cabling with that. And it would look like this. I have one of the folks I work with here that has a fun little demo and jokes about, hey, this technology is so good that we can run your connection over barbed wire on a fence. And we've done a lot of testing in the labs and kind of with some of our partners, showing some interesting applications of what you can use. But generally, we like to see this used with twisted pair cabling. And to kind of look at how this is used, just in a common scenario, you'd look at having on the left-hand side Ethernet over on the left and the Ethernet over here on the right, and then basically being able to bridge or join those connections over unconditioned, low-quality, twisted pair cabling to connect those. And notice one of the interesting things here is that there's only a single twisted pair of wire. So basically this pair of wire is able to both transmit and receive Ethernet to those end devices and do so over some extremely long distances. So again, your local connections both on the local remote side are going to have your 300 or so feet on both sides. But the interesting part here, and they'll highlight that with a red dot, is that you can go in some cases distances of up to 5 miles with this technology. All right, so pretty impressive. Great if that's infrastructure you guys have in place. If you're an end user and have a plant or a mine or some type of application where you've got that twisted pair copper installed, could be in maybe even more of a campus environment where that's in place. This is a great technology to drop it in place. Though there are some caveats with this technology too, so I wanted to kind of underscore, and we'll talk about this more in a couple successive slides, that with your distance comes some limitations. So when I do that 5-mile distance, the trade-off is I can't run that Ethernet at 100 megabits. It's somewhat slower. But let's look at that in a little more detail in the next slide. So, and we'll go into this a little more in the next slide. There are some different standards for this DSL technology. Two of the more common ones, and ones that we do a lot of work here with at Moxa, are VDSL2 and SHDSL. And what this kind of is about is the algorithmic processing of the signals on that twisted pair unconditioned copper cabling to be able to move data across those wires. And if you look at the VDSL2, its characteristics really work a little bit better for doing faster speed communications over shorter distances. So, and I apologize, the bottom here shows kilometers, but we're looking at if your ranges are under, say, 2 miles, that you can get some better performance utilizing the VDSL2 type technology. Okay, whereas if, let's say, you've got an application, some examples of this might be rail application, transportation applications. A couple of these are shown on the right-hand side. Maybe a mining application. And if you want to go over 2 miles, this SHDSL technology is a little better for going those distances. The caveat is that you're going to have a little lower speed data that's possible with those on those. Okay, so keep in mind, great technology to extend your distances, but depending upon the distance that you want to go, your performance may vary, and this might point you into a couple of these two different technologies that would be things to look at for your specific application on them. Let's drill down into a little more detail and look at one specifically in mind here. So we're going to look at the VDSL2 technology in this case. And the VDSL2 technology again talks about certain mathematic representations and algorithms of how we bring that signal across the wires. And what I wanted to point out here is that with this specific technology, there's two ways to do this. One's called asymmetric, and that's a little bit like the performance that's delivered to your home if you're using this as broadband. And that means that the upload and download speeds are not the same. And an example is shown here at the bottom of this slide, where you have 1 megabit in one direction and 256 in the other direction. It would be based upon your application, and this might be good for an application maybe where you're doing a polling type application. Perhaps you might be using Modbus, where the request to get data is very short. It's like, hey, tell me the tank level on this tank and give me the couple registers of data. So that poll request might be rather short, but the data coming back might be, say, 4 times larger. So asymmetric means the characteristics of your application layer of data, if you don't have to have symmetric for transmit and receive being used at the same time. Versus symmetric, symmetric means that you have the same performance on upstream as well as downstream. An example of this might be, maybe you might have to do some level of video conferencing in your application. So you might have a control room person talking to an operator, and you might be using some type of technology to do maybe a video chat where that's important, or doing remote troubleshooting where you need to have the same level of bandwidth capable downstream as well as upstream. And this means that in using this, you might be limited to 1 megabit per second at that maximum distance. So I know this gets a little detailed, but it's good things to know about when you're looking at these extension technologies and when you go beyond what you can do with a switch, particularly looking at what can be done with this interesting technology called, digital subscriber line. You have to look at your application requirements. How long do you need to go? What is your data rate? And does it have to be equally balanced for the upstream and downstream for that? Okay, great. So didn't want to get too hung up in the bits and bytes and all of the technology here. Again, we wanted to highlight some really great tips and techniques with which to extend your Ethernet connections. And again, this is one of those to look at. So let's move on and kind of take a little look here at wrapping up on this and take a look at kind of what those considerations are. So we touched this on the last slide, right? Remember that a DSL extender is not a DSL modem. If you were to purchase one of these and play with it, you can't hook it up at your house and be able to get internet service at your home. So they're really not meant for commercial broadband networks. They're meant for specific industrial applications to take this technology and apply it to those industrial applications to extend Ethernet over twisted pair, preferably, but at the very least copper cabling. And yeah, we've seen it go over barbed wire on a fence post, but your performance varies based upon the quality of the cabling you're working with that. Okay. One of the ways that, and this is kind of a telco term used, dry loop. Dry loop means that unconditioned copper cabling. Dry loop means we don't have dial tone on those wires. We don't have a battery. We don't have a PBX in between the endpoints on that. What it means is, point-to-point copper connections, maybe through a patch panel, but nothing in between it to do conditioning. And of course, point-to-point connections, right? We're not going to be able to do multi-drop with this technology. It's not the same. Some of you may have had experience, and we do a lot here at Moxa with extending serial connections, such as using RS-485 technology to do that, which has the ability to do multi-drop. But with this DSL type technology, it's point-to-point. If you need to do more than 2 connections, you'll have to insert a switch at one of those points and kind of do like a star technology to branch out from there to be able to do those types of things. And of course, and I think I've mentioned this a little bit as we've been going through the tips here, your performance varies, by the cable quality and distance. For these commercial standard or existing standards, you saw a little bit in this past few slides showing a few charts. For example, with some of the products we work with here at Moxa, you can easily take a look at one of the user guides and see charts that will give you performance metrics and how to gauge this up, which technology to use for which application under 2 miles versus more than 2 miles, and symmetric versus asymmetric. But it's a good question. If you do have more questions, I'm not sure we can answer these in today's webinars, but certainly, feel free to reach out to us and speak with one of our application engineers that can help you with some application guidance, more in terms of your specific application and what you're trying to achieve. We'd be happy to help more of what you can. We're kind of wrapping up here and a little bit of a review of the past slide. Remember that you need to kind of take a look at symmetric versus asymmetric. Again, symmetric means your upstream and downstream speeds are equal. So 1 megabit up and 1 megabit down, maybe we had to do video conferencing between sites, versus asymmetric, which might be good for maybe doing polling or maybe file download where we have to download from a server, things of this nature. Last one that wasn't intuitive here is you need to use these in pairs. So while there are established standards, the best performance is using these in pairs by the same manufacturer. That means you're going to be able to speak to someone knowledgeable to help you set that up and show you how to use this. And one of the things that you're going to see is a little terminology. I didn't really want to get too far on this, but you may see the terms CO. CO is a telco term referring to central office. That's that, AT&T building or Verizon building or your local telco building that you might see nearby in your community. That's where you terminate all those wires to. Whereas your house is the customer premise equipment, that is CPE, and this is kind of the terminology that kind of bleeds over here into the commercial usage of this technology, whereby that's the box at the other end. It doesn't matter which one's there as long as one's the CO and one's the CPE. And even in some of the implementations, like here at Mox, we've tried to make this easy. There's an auto setup that'll auto negotiate that, but it does take a few seconds for that to kind of do its magic. Good to know about and good to think about if you're considering this technology for your application. Great. So tip number 2, DSL extender. Extend those Ethernet connections up to, in some cases, over 5 miles. A couple things to think about with this technology, as you're thinking about deploying it. All good stuff. Okay, we're doing good for time. Let's look at tip number 3. This is one of my favorites and one of the least understood. Maybe a lot of you folks here joining us today have never had a chance to work with fiber. And a lot of times that kind of involves bringing in a contractor, building a new facility, working with other companies, suggesting this perhaps to one of your end user customers. And there's not really any magic to it. What you need to do is think a little bit more about outside of the box and thinking beyond maybe what you've done in the past. And maybe a little bit of maybe going back to maybe some of you might have done a little bit back in high school physics. So I'm going to kind of jump into this a little bit and talk a little bit about that high school physics for a second. So I think it's really important to understand it, but don't be put off by this, and kind of look at what this is about. So here's where we're kind of bridging that world of moving data in terms of electrical signals on a wire to turning this into little pulses of light that travel down a piece of glass fiber. And in fact, one of the great demonstrations of this, all of you that are listening to this live today, and even those that you may be listening to this on a recording, you're probably listening, and not probably, like you're all with the exception of maybe Marty here across the room from me, listening to this via the technology of fiber optic cabling. And the way this works is we're able to bounce light down a fiber that's about the size of a human hair, that's able to capture that light and make it bounce down that, spanning the globe. We've probably got a few folks today that are listening, internationally. And this works by that old property, and you might have done that little science experiment looking at, water within a glass to see how that light bounces through this, or if you were to look at how prisms work. So great magic, lots of great stuff on here. If you're interested, there's lots of great resources online. I think we have some at moxa.com to show that, working with that refraction index. That's one of those great physics properties to do that. Now, just a couple little basics of this. Now, without delving into a lot of that magic of the refractive index and fiber, there's some great properties of optical fiber. Number one, and a lot of you folks probably already figured this one, right? If we can move this to pulses or waves traveling down an optical fiber, we get away from having to worry about electromagnetic interference. So arc welders, RF sealers if you're doing packaging equipment, radios if you've got radios nearby, all of that goes away. You have total noise immunity, which is great, which is a great property of using fiber. Isolation. Hey, we're not dealing with electrical signals, so you can have different pieces of equipment at either end of the fiber, and they can be powered by different sources and be at thousands of volts at different potential relative to ground. And it doesn't matter because you have total optical isolation. And some of you folks, being engineers working with maybe other signals like serial ports, a lot of times if you're working with serial ports, grounding is really important, and ground loops can be a big problem. And you probably would choose products that have optical isolation, utilizing an opto-isolator, which is a little mini fiber optic media converter on a chip that's within the products to do this type of thing. This gives you total isolation from ground loops, ground faults, and even lightning. And the other property with optical fiber that's really exciting is that depending upon the technology that you use, a little bit like DSL, You can go distances above 40 plus miles. There are some standards that are emerging to go even beyond that. We'll talk about that a little bit more, but we're not going to go into all the details. But you can go extremely long distances. One of the common scenarios is with municipal deployments, across the city, where you're maybe doing things like connecting traffic signals, connecting traffic sensors, rail applications where you're going between metro stations. Lots of really interesting applications where you want to connect Ethernet, but you want to kind of overcome those distances with those. How do you do it? It looks something like this. Real simple to that first scenario we started with tip number 1, where you're going to basically use 2 Ethernet switches, or I'm sorry, it looks like 2 switches, but 2 switches with special ports built in that are fiber. And in this application, we've got an Ethernet on both ends again. And if we kind of look at the left over here, here's your Ethernet with Cat5 cabling, and you're going to convert that back to Ethernet with Cat5 cabling. But in between, you're utilizing optical fiber, and the smarts is within these media converters, it has the technology to convert that, to do that. So if we take, a real inexpensive, real common type of fiber being used, and don't worry too much about the terminology here. We'll talk a little bit more about that on the successive slides. But you take a real common mode, commonplace multi-mode fiber type cable, and we use, the least expensive, most common type of media converter. You can go, up to about a little over a mile with this type of technology. So really cool what you can do. One thing to point out here, you will note that there are actually 2 fibers used for most technologies, or most applications. One is a transmit and one is a receive. So this one here transmits to this one to receive, and this one transmits back to receive over here. So one for transmit, one for receive, kind of swapping those cables amongst the media converters. Both are the same media converter and used in this configuration. So really cool technology. We're talking about media converters, just to give you guys an idea of $100 or so on both ends, and doing some, really cool applications like this for your application. Applications might range from a factory floor environment, or you've got to go further than that 300 feet, or going back to a control room where you want to ensure the data integrity, you want to overcome the distance, inter-building connections to span part of your plant back to the control room. Basically anywhere you want to extend these connections reliably, repeatably, and not be susceptible to noise. Some of the commonplace technologies here, and some of this you can find on moxa.com. Another resource that I kind of like to reference is Wikipedia, and you can see some of the different type of standards here. Working on the left-hand side for the common standards, and I know this looks a little dry, and we've got these 100 base FX, SX, LX, and they kind of all look the same, a little bit of a blur. But what you're seeing is some of the existing standards for the technology. Some of these depend upon speeds. Some are reserved for 100 megabits per second, and some are reserved for the gigabit technologies. But what I want to do is give you just kind of a couple highlights of what you can deploy. In the example we took a look at before, the most common is the 100 base FX, and utilizing multi-mode fiber. This is where you get that almost a mile type of coverage with that for 100 megabits per second. This is again one of those application considerations you're going to look at. And there's more standards available. These are the most commonplace. And I think a lot of the applications kind of fall under that, under a mile and well beyond a mile, that kind of gets into those municipal, campus, large factory type applications for these. I did want to point out here that on the connectors, this is kind of not the only types of connectors, but maybe the ones you see most commonly deployed. And when we get into the gigabit connections over here, I did want to say that a lot of this technology uses something I'm going to talk about on a successive slide, and you may see that this only has an LC connection based upon the technology used here with that. But just as a means here on this slide to kind of give you a little bit of a little perspective on what's out there commercially for these different technologies. Okay. Couple considerations. So let's talk a little bit more, and one of the things I didn't talk about that may be new to a few of you folks is the multi-mode versus single mode. Basically, this talks about two key things: the construction of the fiber and the electronics at both ends. In short, multi-mode is the most common and can be used up to a couple of miles for most applications. We find this, within the plant type of applications, and generally the most inexpensive. Multi-mode also means that we can utilize inexpensive LED light sources and photodetectors at the other end of it. That means that the technology that has to be designed into the product is very very inexpensive, very easy to deploy. If you need to go longer distances, it takes a more precise light source that's generally based upon laser type principles and higher power that gives you the longer distances. So multi-mode versus single mode. Also an important consideration, if you're working on a project with a customer or with a systems integrator or with somebody else, beyond your company, important for the coordination to make sure that the proper type of cabling is installed. If you're picking a media converter that uses single mode, you got to make sure you have single mode fiber installed on this one. Next, connector types. So these connectors all perform the same function. They interconnect the various devices. None of them are better than another. They all do the same function. It's more about, what is your convention? What are you connecting to? I kind of like to remember these in a couple different fashions. And depending on what type of industry you're in and what you're doing, you may find some different types. If we talk about the ST, this has a bayonet style connector that you twist in and locks by rotating about 20-30 degrees. Think of the T and ST as twist. This is nice if you're in an application where there might be some potential shock or vibration and you want that positive connection to twist and lock into it. Again, the other type of connection might be SC. You can think of the C as a click. You'll push it in and it has a little bit of a detent to click into place. Again, you'll typically see these in pairs. Again, you see one transmit, one receive. Again, SC, transmit and receive. And then over here on the LC, I kind of think of that as a little click, L for little. The connectors themselves are a little smaller, and the end of that, kind of the size is a little different. This connection here is about the size of a AA battery. This is about half that size for both of these side by side on here. So this is the LC. You might see in a little more of the IT type environments, the MTRG type connector that looks like this, that is duplex with two connectors, also a small form factor that's better for high density applications for those. With that. Also remember the speed, okay? With deploying fiber, you need to know the speed of that fiber connection. Fiber does not auto-negotiate like a RJ45, 100 base TX connection does. So you need to know what the speed is on that link. This is also important for the electronics on the both ends of that. And lastly, a little bit more of the application environment, right? And this is maybe a little more, not so much optical fiber considerations, but packaging considerations. What's the available power? What's the mounting? This might be even important for you doing tip number 1, where you're going to install a switch in that environment, right? And good things to think of, irregardless of, the technology you're deploying. So a couple things to think about for tip number 3 in the optical fiber considerations with that. Now, one technology I want to spend a few minutes on, and we're kind of getting close to wrapping up. Hopefully you guys are getting a lot out of this today. I see we're getting a couple questions queued up, and we'll have some time here for the Q&A coming shortly. But there's an interesting technology I wanted to spend just a few minutes on to share with you folks today, called SFP module. And this is a modular fiber optic transceiver. That SFP stands for small form factor pluggable. It was developed by a consortium of IT companies getting together to kind of solve this problem of different people, different customers, different integrators having different requirements, and making it industry standard to be able to take a media converter or a switch with media conversion built in, and having an ability to customize it based upon the application. And this really helps on those projects where somebody goofed and they said, darn it, I need to have multi-mode instead of single mode. And instead of just switching out the media converter, switching out a switch with media conversion built in, that you can do this. So this little SFP module that we're looking at up here, again, always being remote, it's always hard for you folks to kind of get a gauge of size on here. And if I were to lay a AA battery side by side, it's about the same size of that, or maybe the size of your small finger. And the electrical connections on the right-hand side plug into your media converter switch. And here's your fiber connections that accept that LC connector over here on the left. This is a really great technology. It's also hot pluggable, so you can remove and install this under power. And the really key part of this technology is the ability to have it available in different types of configurations. So here's where you customize it for your application, multi-mode or single mode, 100 meg or gigabit, and also another thing to think about when you're looking at this technology, standard temp versus extended temp. So if you're doing a project outdoors, doing data collection for a PV solar array, or you're doing a municipal application, or you're doing an outdoor weather station, whatever this might be, you're going to want to make sure that you use that extended temperature rated for outdoor use, without having to have air conditioning on that control panel. So lots of good stuff. And again, maybe a little bit of review from some folks, but really great technology for doing that fiber connection at the fiber itself, utilizing modular fiber transceivers known as small form factor pluggable with that. Okay, good. With that, we're kind of wrapping up the content session of this, and hopefully, with these 3 tips, we've been able to give you a couple ideas of the technology. And let's just do a quick summary on this to kind of compare and contrast those. After this, we'll go ahead and open this up to take a few questions via online chat with some help from Martin over here. And let's just take a quick look. Some of you might recognize this as the consumer report style of comparison. Solid red's excellent, black is unacceptable. So let's take a look at the switch technology. So kind of if we rate this in that means of doing that, we've got a couple things here. Not very good distance. We're still stuck with that 300 or so feet with each link, but you can cascade switches to do that. Isolation, not much more than a switch, by capabilities of Ethernet with that with that galvanic isolation transport coupling. Not bad, but not as good as some other technologies that are opto-isolated. Real low-cost media, we're talking about extending with plain old Cat5 cabling, and pretty good, in terms of the hardware costs. You can use an inexpensive unmanaged switch for this, right? So there's kind of the wrap-up if we were to look at the DSL technology, or the switch technology. Let's jump to DSL. I'm getting ahead of myself here. DSL, pretty good distance. Not as long as some of the things we talked about. Not so good isolation, only about as good as Ethernet can do on itself. Likewise, in terms of some of the other things, really low cost media, maybe even a little bit lower cost than Cat5 cable. However, the technology on both ends is a little more advanced, so the hardware costs are going to be a little bit more for that. And then lastly, let's jump over to our last selection here, being the fiber media converters, or Ethernet media converters, as a lot of people kind of call them. This one gives you kind of the best of all of these capabilities. We've got the ability to go extremely long distance, so we talked about 40+ miles. There are some non-standard implementations that are vendor specific or maybe not ratified yet that can go in excess of 70 miles. We have excellent isolation by being able to utilize that capability to turn the electrical signals into light pulses. We have media that's not quite as not quite as cheap as copper cable, so we have to worry about installing fiber optic cable and protecting it. That might mean burying it in a trench, and then of course the fiber optic media converters there, kind of in between the 2 technologies above here. So hopefully that does a nice wrap up for today's topic and giving you some ideas of different types of technologies to use on this. With that, and I'm going to ask for a little bit of help from my partner here, Martin. Let's open this up for some questions and see what we have here. We do have some limited time, so it may be that we can't get to everybody. We'll try our best. And Martin, what do we have?
Great, thank you so much, Paul. Awesome information. The first question I have is from Michael. Michael asks, I see the fiber media converters have two fiber connections. How do I connect between these devices?
Oh, good question. I think I covered that briefly, but I know there's a lot of material here, especially if this is a little new to some of you folks. And I think it's important to remember that number one, and Michael, you got that, which is great. Two fibers required on that. I did want to point out that oftentimes you'll buy that as a bundle. You can buy pre-done cables in short distances, up to a couple hundred feet that are pre-terminated. Based upon your application, you might bring in a contractor, or you might have a specialist to do that, to terminate that for you. And when you do connect that to the end devices, you want to make sure that the transmit on one media converter goes to the receive on the other. And I'm an old communications guy here, so I'm used to doing like RS-232. Transmit on one goes to receive on the other. Same thing with fiber. So transmit on one end to receive on the other, and then in the backwards configuration, then the receive to transmit. So you have to do kind of a crossover capability. And maybe some of you folks remember Ethernet back in the old days when you had to have a crossover cables. The same thing as old school Ethernet before we had these great things called switches on that. Martin, what do we have next?
Great, thanks, Paul. This next one I have is from Kalen. He's asking, how do you set the role of the DSL gateway in the asymmetric VDSL2 mode? For example, how do you determine which direction is throttled and which has the higher bandwidth?
Oh, another good question, and we tried to cover as much as we can today, but I think that's really pertinent to maybe a basic understanding of it. And that role is really set on the configuration of the device. In what we've kind of brought to market from Moxa, we've kind of approached this from a couple perspectives. We know sometimes you want to just get something quick and easy up and running, and one way to do that is via dip switch selection, that you can set the role of the device, where you can set one device to be the central office or CO, and the other side is set opposite for the CPE. So this is a manual configuration that you have to do on each device separately. The other option is in our implementation, we've made this work like a managed switch, meaning that you also have a web interface that's capable, and you can also connect via Ethernet utilizing a web browser to assign these roles. So short and simple, each end has to be set up separately, and you do that via dip switch or via the web console. There is kind of an in-between or a third answer to that being a auto configuration where you can have these two negotiate. The problem is that does take a little bit of time to set up, and there are some caveats. I'd kind of encourage you to talk to one of our application engineers if you're considering that, to kind of fully understand the caveats on that, or to take a look at one of the user manuals on that to kind of give you a little more detail. But great question, and really helps to kind of drive that you have to understand the two roles between each end of that connection. Martin, what else do we have?
Great, thanks, Paul. So another question in regards to the DSL extenders, and this one comes from Marty. He wants to know, in regards to UDP, being able to arrive at each endpoint, the time to life for those UDP packets as it pertains to the DSL extender. So maybe you can provide a little insight in specifically in regards to those aspects.
Yeah, another good question as well. And I think what I want to do on that one is kind of emphasize is remember your 7 layers to a network, 7 ISO layers. We're dealing at that very low end on a DSL extender at the media level, where we're talking about how that signal gets passed across on this one. And as such, this technology is not limited to IP communications. If you had some other standard, you could run this over Ethernet. It's just that, running IP technology over Ethernet and transparently over this DSL technology is quite common. I think from what you're asking, you would see no issue with that. I don't know specifically offhand without kind of taking a quick look or talking to one of our application engineers. The latency we're talking about here is very, very minor. And you would see it, orders of magnitude lower than what you'd see in typical types of response times on that. So when looking at the higher level application protocols, I would see no issues with doing common UDP type communications. You're seeing latencies on the order of what you typically see through a couple of switches. And hopefully that answers your question. If not, I believe Martin's going to kind of send out a little summary after today's webinar. There'll be more information on there if you'd like to contact us to have more of a follow-up discussion with one of our applications people.
Awesome. Thank you, Paul. The next question I have is from Witham. He's asking, all DSL extenders are transformer coupling to the outside plant cable, and there's no galvanic connection from the electronics to the outside plant. Therefore, I think the isolation should be good or excellent. Would you care to comment on Witham's observation or insight?
Yeah, maybe I probably should have, I'm looking back to the Consumer Reports chart, and probably should have had maybe a little better definition of the grading on that. But understand that with the DSL technology, and it's interesting, a lot of people seem to be interested in this, which I'm glad I happen to include that as one of the tips, that you're basically, working with a normal Ethernet connection, equivalent to having an Ethernet switch there. So you've got, good protection. In most applications, and if you're kind of, looking at, what types of disturbances you're going to have, and since you said factory environment, I'm assuming that you make sure that the types of cabling is separated from high voltage, like three-phase 480 volt type signals and VFDs and all the nasty stuff that you can have in different types of factory environments. If that's the case, you're great. Anything other than that, that's really the time to start thinking about optical isolation and utilizing a fiber media converter on that, right? And again, the other consideration is what's installed. A big play on which technology you use is based upon, do you have copper cabling installed? Looking at one of the projects that we've seen some really interesting use of this technology is in mining applications where there was voice-grade cabling in place, and they're trying to reuse that existing investment. A lot of times you'll find this in factory applications. There's even a nuclear power plant that is another application we're working on that has voice-grade cabling, and they're trying to put in new monitoring and instrumentation. This is a great, use of that existing technology. By the way, a little tidbit here, within nuclear environments, fiber is susceptible to radiation and cannot be used in a nuclear environment. That kind of helps them in their decision, but maybe not so much for you guys with that. But lots of great questions. And Martin, how are we doing for time? Can we take maybe one or two more?
Yeah, I think we have time for two more. The next one I do have is from Kalen again. His question is about wire gauge, the impact of bandwidth on DSL. So does wire gauge give a better performance or cause the signal to degrade? Maybe provide some insight on the gauge of the wire.
Yeah, I think the other factors, and I didn't highlight these because I wanted this to be, really the highlights of this. Wire gauge are not as important. I can't recall offhand our recommendation. It might have been 22 gauge that some of the testing is done. I'd really refer back to take a look at that specifically. What I wanted to get to, Galen, was really the twisted pair aspect of it. Now, it looks like, hey, that's just a neat way to pull cabling and do stuff, but basically that twisted pair is important for canceling noise that comes in separately. So if anything, I would kind of point you back to look at your application and to make sure you're using twisted pair cabling, and basically, what we talked about jokingly utilizing, barbed wire and a fence pole. That's a bad application because you're not going to have any intrinsic protection from EMI because it's not twisted. So there's a couple of things to look at. I think there's some good reference information. I think we've also got a white paper that's up on our website that kind of goes into a little more detail of that. So in short, the wire gauge is not so important as the quality of the cabling and that it is twisted pair and also routed separate from other types of signals. So that's my guidance to you. Again, if you'd like to delve into that more, I kind of point to kind of reaching out to us after the webinar. We'd be happy to put you in touch with one of our applications people. Martin?
Awesome. Thank you again, Paul. The last question I have is from Anna. Anna asks, are fiber connections like Ethernet, where 100 meters is backward compatible to 10 meters?
I think that when I see here the backward compatible, it might mean that that's megabits per second. And that's a really good question as well. And one of the things, and I think we've gotten used to working with Cat5 cabling, right? You pull it, and if you did Cat5e, that's good to run 100 megabit Ethernet, but you could also run gigabit over it because it has the same types of properties. And that's not the case with fiber. You got to be more careful with this and make sure you're putting in the right fiber specifically for choosing and what's on the ends of those connections. So in the case of this, if you're running 100 megabit per second, you better make sure you've got 100 megabit per second capable media converters in both ends. The media converters are not able to translate with that because the fiber optics are not as sophisticated and they're more specialized than the Ethernet, MAC, and transformers that are on the other ends of the Cat5 RG45 connection for that, right? So pay close attention to what's being connected on both ends. It's always good to utilize, but it's not always required, but it's always good to utilize the same manufacturer devices. The next best thing is using SFP modules, making sure you use the same exact SFP on both ends. So probably a good question to wrap up on. Martin, I'll let you kind of do the closing on that, and I know we're going to have some of this available to folks that have joined us today. And before I do, I want to tell, I know all of you folks are busy. I appreciate you for joining us today, and really hope that all of you kind of had a takeaway with learning at least a couple of new tips and techniques for extending your Ethernet connections. And thanks, and I'll turn it over to Martin.
Great, thanks, Paul. We are at the end of our session. We've had a few more questions we have time for, but please know that we'll get those questions answered, and we'll respond separately via email. So again, thank you to Paul, and thank you to everyone for your interest and participation. Thanks again for tuning in. Have a great rest of the week, everyone. Bye now.